Okay, so we are given an NFA and we have to find, it's a null NFA, as you guys can see. It is nothing but a null NFA, and what we have to find, we have to find the DFA for this null NFA. So we will start with state 0. So what is the first step? What is the step? There are two steps only. The step 1 is find the epsilon closure, for all the states. This is the first step. What is the second step? The second step is to draw the DFA table for each state. Okay, this is the step 2. And what is the step 3? Finally construct the DFA with the new states. Okay, so make the DFA with the new states. So these are the three steps which we need to do in order to make the DFA from this epsilon NFA. So first of all, what is the step? We have to find the epsilon closure for all these states. So first of all, I will find the epsilon closure for 0. Okay, so epsilon closure for 0. So from 0, what are the states that I can reach if I give epsilon? So from 0 I can reach 1, then from 1 I can reach to 2. So 0 to 1, 1 to 2, and then from 1 I can also reach to 4, and then from 0 I can directly reach over 7. So 0 to 1, 1 to 2, 1 to 4, and 7. So 1, 2, 4, and 7 are the states that I can reach from 0. 1, 2, 4, and 7. Now I have to make the same thing for 1. I have to find the epsilon closure for 1. Okay, let's see. So the epsilon closure of 1, what I will get? So here I am in 1, so if I give epsilon I will go to 2, but I am not gonna be going to 3 because I don't have epsilon over here. If there is epsilon, then I can easily push from 2 to 3, but there is no epsilon, so I can't do that. So from 1 I can go to 2, or from 1 I can go to 4. So I can only reach two states. The first one is 2 and the second one is 4. Now let me find the epsilon closure for 2. See, I am in 2, so from 2 I cannot go to any of the states, right? I cannot go to any states by epsilon closure. So from epsilon closure of 2 is nothing but it's just 5. It's not any state, it's just 5. Okay, now my next step is to find the epsilon closure for 3. So from 3, where I can go, if I give the epsilon closure, I can just only go to one state, which is 6. So epsilon closure of 3 gives me 6. Got it? Okay, now I am done with 3. I am in 4. Okay, I am in 4. So what is the epsilon closure of 4? So I am in 4, and if I give epsilon I go nowhere. So epsilon closure of 4 is 5, nothing. Now what is the epsilon closure for 5? See, I am in 5. If I give epsilon closure, where I go? 6. And from 6, if I give, wait a second. See, when I was calculating the epsilon closure for 3, so I am in 3. For one epsilon I go to 6, and the second epsilon I go to 7. So there are two states which I can reach possibly. So epsilon closure of 3 will be 6 and 7. So this is my mistake. I just missed out. Now what is the epsilon closure for 5? So from 5 I can also reach two states, from 5 to 6, and then again there is epsilon, so from 6 to 7. So two states, 6 and 7. So let me write this. This is 6 and this is 7. Okay, so this is also done. Then now I am in 6. So let's find the epsilon closure for 6. So what is the epsilon closure for 6? So I am in 6. So for one epsilon I go to 7, and there is no more epsilon, so I cannot continue further. So epsilon closure of 6 gives me 7. Okay, so this is the state. Now what is the epsilon closure for 7? Let me find out. So what is the epsilon closure for 7? So I'm in 7. If I give any epsilon closure, where I go, there is no epsilon closure, I can't go to anything. Now you can say that, what, if I give epsilon closure, then I can reach 7 only because epsilon means nothing. Yeah, that's true, but what's the need of that thing, right? So from 7 I can't go any other state with the help of epsilon, so I will just write epsilon closure of 7 as 5. What's the need of just coming to the same state again, right? So same, the epsilon closure of 8 is also 5, the epsilon closure of 9 is also 5, and the epsilon closure of 10 is also 5. So I'm just gonna be writing those because that's a protocol I need to complete. Epsilon closure of 8 is 5, epsilon closure of 9 is also 5, and epsilon closure of 10 is also 5. Okay, so I'm completed with the epsilon closures. Now what is my next step? My next step is draw the DFA table for each state. So I have to make the DFA table for these new states. Okay, so this might be a bit confusing, so in order to make it more simple, let me do something like this. Let me do a short trick. What is the short trick? So let's say this state 1247, its name is A. Let's say this state 24 has a name B. Let's think, assume that this state 67 has a new name which is C, and this is also 67, so it will have the same name, that is C. Now I can make the DFA table. Okay, so how will I make the DFA table? So this should be like this. So there will be only two inputs. As you can see, in DFA there is no null. I hope you guys know that thing. So there are only two inputs. What are the two inputs? The first input is A and the second input is B, as you guys can see. So I'm just gonna be writing two inputs. One is A and another one is B. Okay, so I will start with the first state. What is the first state? Which is A, 1247. So I'm just gonna be writing over here A. So if I give 1 2 4 if I give the A input, small a input to this A state, what is this A state? 1247. Where will I go? So 1 2 4 and 7. See, one thing, if I give, see, if I give A to 1, I will not go anywhere. If I give A to 2, where I will go? I will go to 3. So I'm just gonna be writing here 3. And then what is it? 4 and 7. Let's check. If I give, wait, check this thing. If I give 2 to A, if I give A to 2, I will go to 3. That's okay. Now 1 2 4 7. So for 1, if I give A, I don't go anywhere. So if I give A to 2, I will go to 3. If I give A to 4, I will not go anywhere. And if I give A to 7, where I will go? I will go to 8. So from A, I'm also going to 8. So this is 3 8. Okay, now what will happen if I give B input to this? See, I'm in state 1. If I give B, I won't go anywhere. I'm in state 2. If I give B, I won't go anywhere. I'm in state 4. If I give B, where I go? 5. So I will go to 5. Okay, next I'm in state 7, right? I'm in state 7. So if I give B, where do I go? I go nowhere. So I will just only go to one state, that is 5. Okay, now I get a new state which is 3 8. Okay, so let's mark this state as D. Okay, D means 3 8. Okay, so if I give A to 3 8, where will I go? So this is 3 and this is 8. So if I give A to 3, I don't go anywhere. If I give A to 8, I also don't go anywhere. So if on A input, it doesn't go anywhere. Now let's check for B. 3 8. So I'm in 3. If I give, B, where do I go? I don't go anywhere. And I'm in 8. If I give B, where do I go? I go to 9. So this is a new state 9. Done. So next I will be covering these states 5 and 9. Okay, so I don't think there will be a need because I think I will be getting 5, but let's check. So I'm fifth state. What will happen if I give A and B? So I'm in fifth state. If I give A, I don't go anywhere, and if I give B, I also don't go anywhere. So I will just get 5 and 5. Now I will define the same for 9 because I need my DFA table to be more precise. Okay, now I'm in 9. So if I give A, I don't go anywhere, but if I give B, I go to 10. So 9, if I give A, I don't go anywhere, and if I give B, I go to 10. Now I get a new state which is 10. Now I have to define this 10 state. Okay, so let's try to define this 10 state. So I'm in state number 10. If I give A, I don't go anywhere, and if I give B, I also don't go anywhere. So for 10th state, A and B both will give me 5. Okay, will not give me any state. Okay, now it is complete. But now the 1 to 4 7 part is complete. Now I have to check for the 2 4 part, right? This part. So what is the name of this state? B. So let me make this transition table again. Okay, so I'm in state B. What is the state B? It is 2 4. On input A, where will I go? C. 2 4. So first of all I will see 2 and then I will see 4. So on 2 if I give A, I go to state 3, and on 4 if I give A, I go nowhere. So I just go to state 3. So B, on input A, I go to state 3. And what happens on B if I give the input small b? So 2 4, right? B means 2 4. So I'm in 2. If I give small b, I don't go anywhere. And if I give you know what, I mean 4, if I give small b, where I go? I go to 5. So I go to 5 over here. Okay, now I don't need to define 3 and 5 because I know I have defined, oh no, I have not defined 3. Let's define 3. But I know if I give 5, if I go to just 5, nowhere else. No, I just don't go anywhere. Now let's define it for 3. Okay, so for 3, what do I get? So I'm in state number 3. For A, I don't go anywhere, and for B, I also don't go anywhere. So 3 gives me 5 for both the inputs. So this 2 4 is also completed. Now what next I need to do? Now next I need to solve this one, 6 7, which is the state C. So I'm in state C. So the state C 6 7. So let's see what happens if I give input A and then input B. So I'm in state 6. If I give input A, where do I go? I don't go anywhere. So it give, and if I'm in state 7, if I give input A, where do I go? I go to 8. So from C, if I on input A, I go to 8. Now let's see what happens to C state when we give the input small b. So I'm in C. C is what? 6 7. So I'm in 6. If I give the input B, okay, if I give the input B, I don't go anywhere. And I'm in 7. When I give the input B, I also don't go anywhere. So on, if I give the input B on this C state, I get 5. Okay, so is this also defined? Now is there anything left? Yes, I need to define this state 8. So let's define this state. What will happen if I give the inputs A and B to this state? Okay, see, listen, watch carefully. I'm in state 8. If I give A, where do I go? I don't go anywhere. But if I give B, I go to 9. So if I give A, I don't go anywhere. But if I give B, I go to 9. Now see one thing. Now 9 is previously defined. See, 9 is previously defined. So I think I have completed my DFA table, which looks something like this. Now I need to make the states. So what are the states? See, the states are A, D, 5, 9, 10, and then B, 3, C, and 8. So there will be this much amount of states. Let's draw the table. It's not important. So now I can just eliminate some dead states like 5. This can be eliminated because A and B both gives us nowhere. 10, this can also be eliminated because this also gives me nothing. And 3, this state can also be eliminated because this also gives me nothing. So we are left with these states. So let's first of all see this A state. Now see 3 8. Have I defined this 3 8 state? Yes or no? Yes. This 3 8 state is nothing but D, right? So I am in state A. Let's try to draw the DFA. See, I am in state A, right? On input A, small a, I go to state D, which is 3 8. Okay, so on input small a, I go to state D, which is 3 8. Now what happens if I give the input B to this state? So if I give input B, okay, so where do I go? I go to the state called 5. Okay, so this state, this is the state where I'm gonna be going. Okay, next, so this D state, this is the D state. Now I have to define this state. On A, where do I go? Just see the transition table and try to draw. Okay, so on A it's showing I go to 5, so I don't go anywhere. And on B I go to 9. Okay, so if I give B input, where do I reach? I reach 9. Okay, got it. Now next, I have to define 9. So on A, if I'm in state 9 and if I give A, where do I go? I don't go anywhere. But if I give B, I go to the state called 10. So let's say I give input B and I go to a new state called state 10. Okay, no problem. Next, I have to define the 10th state, but it's not required at all because it gives me 5. So no need to define the state. Okay, now there is a state called B which is 2 4. So if I give A to this state, I go to 3. Okay, which is not existing. Let's make this. Okay, so this is the state. If I give A, I go here. And what if I give B? If I give B, I'm gonna be going over here. So I just make this DFA more clumsy, but okay, just cope up with me please. So this is the thing. Now see, this is done. So I have defined for B. Next I have to define for the state C. Okay, so let's assume there is a state called C over here. Okay, so this is the state C. So what will happen if I give the input A? So if I give the input A, I will go to a state called 8. Okay, so I'm gonna be making this 8 state over here, and I will go over here when I give the input A. Okay, and what will happen if I give the input B? So if I give the input B, I won't go anywhere. Okay, and now I have to define the state 8. I have to make everything connected. If something is disconnected, then we don't need to include that in our DFA. So I'm in state 8. So on input A, where do I go? I go to 5. That means I don't go anywhere. And on input B, where do I go? On input B, I go to 9. Okay, so that makes my DFA fully connected. Okay, so this is my DFA. Okay, I hope you understand. This is the required DFA which I have made from the epsilon NFA. I know this looks a bit weird, but this is the actual drawing. So you have to make this entire DFA. Okay, so thank you for watching.